Hello everyone, welcome to Basics e-learning.
In lesson number 4 video, I am going to explain few problems on star delta transformations. In the previous 3 lectures, I have explained the basics of network analysis and also the derivations to star delta transformations. Also in my channel, I have explained few lectures on signals and systems. So the link of which I am going to leave in the description box. Please go through it. The first problem that I have selected based on this star delta conversions is very simple problem. Find the equivalent resistance between A and B in the network shown. So this is the given network and we have to find out the equivalent resistance between these two A and B terminals. So let us try to convert the inside. We have one star, right? This is 2 ohms, 2 ohm, 2 ohm. This star, try to convert this into delta, or else outside delta you try to convert it into star. Anything is fine. So now I will try to convert this star to delta connection. So this star is there, right? So this is 2 ohm, 2 ohm, 2. So for this, I want to find out the equivalent delta connection. See here, I am drawing with the dotted line. So for a clear understanding, so this will be a equivalent that delta connection here. So let us call this as here R1, R2 and R3, right? So if you want to find out that star to delta connection, R1 is equal to, so that will be sum of the two resistances taken at a time, that is R1, R2 plus that inside that you take it as RA, RB, RC, that is your wish, that naming, right? So that you can take it as RA, RB plus RB, RC plus RC, RA divided by opposite to this R1 resistance. What is that resistance? RB, that you take, right? So that you can take. So R1 is equal to 2 into 2, all are 2 resistances only, right? So 4 plus 4 plus 4 divided by 2, right? So this will be 12 divided by 2, 6. Again R2 you write down, numerator is that 4 plus 4 plus 4 only, divided by, for R2 what is the opposite resistance? ZC, that is again 2, 6 ohm, right? Similarly R3 is also here 6 ohm, right? Now these R1 is connected between A and C terminals now, right? R2 is connected between A and B. Again R3 is between B and C. So that will be, if you draw like this, it will come, right? So the equivalent delta for the star, now I am drawing in this color, right? Changing the color to orange here. So that will be here. This is also 6 ohm, 6 ohm, 6 ohm, right? So instead of this star, you can draw this delta. So replacing the internal star by delta, I'll get the circuit like this. So this is nothing but, you can draw this as, this is A, B, C you can take, right? So if this can be replaced by a single resistance here, which is nothing but parallel combination of these two 6 ohms, right? So 6 in parallel with 6, here also 6 in parallel with 6, again 6 in parallel with 6. So this is very simple. So this is nothing but here 6 in parallel with 6 means 6 into 6 divided by 6 plus 6 are half of that resistance, right? So if two resistances are in parallel and are of equal resistances, then it is that resistance divided by the number of branches here. So 2 branches, so 6 by 2, 3 ohm. So this is also 3 ohm, this is also 3 ohm, right? So they have asked you here to find out, sorry, this is terminal B given and this is C, right? So they have asked you to find out the resistance between A and B here, right? So to find out resistance between A and B, look from these two terminals, that is A and B here. So if you look through AB terminals here, so these two resistances will come in series, so that you can draw this as This is my terminal C, node C, 3 ohm and 3 ohm, right, in parallel with another 3 ohm. So this is A and B, right. So 3 ohm and 3 ohm are in series, so that is nothing but 6 ohm, right. So this is 6 and this is 3 ohm. So the resistance between our A and B is parallel combination of 3 and 6. So that is 3 into 6 divided by 3 plus 6. So this is 18 by 9, nothing but 2 ohms. So the equivalent resistance here between A and B terminals is 2 ohms for this problem. The second problem is like this. Find the resistance between terminals A and B in the circuit shown. So this is the given circuit. So if we observe here, this 20 ohm, 5 ohm and 15 ohm, this is looking like a pi connection, right? Pi or delta. So this pi part or the delta part can be converted into star so that the simplification of this circuit is easy. So if you convert this pi to star or delta to star, I'll get the circuit like this. See here, right? Let us call the resistances as R1, R2 and R3. So if you can convert this pi to this star, then this 10 ohm will be in series with R1, 5 ohm will be in series with R2 and 2 will be in series with R3, so that the circuit will be simple. Now let us find out the values of R1, R2, R3. So this is very simple. If you remember the formula what I told you in the previous video, see, for R1 the numerator will be like multiplication of the resistances that are lying on both the sides of that resistance. That is, for R1 here I have 5 and 20. So numerator is 5 into 20 divided by denominator is summation of all the resistances there. So 5 plus 20 plus 15. So similarly R2, if you want, write the impedances 20 and 15, right? So the product of 20 and 15 will be your numerator, divided by denominator is again same 5 plus 20 plus 15. For R3 5 and 15, right? So 5 into 15 divided by 5 plus 20 plus 15. So if you solve, the value of R1 I get here is 2.5 ohm and R2 is 7.5 ohm and the value of R3 is 1.875 ohms. Now replace this pi with star in the circuit. Then the circuit looks like this. 10 ohm with R1 and then 20 I am replacing with, right? So this point you can lift it up so that R1 and R2 will come in series, right? That pi will become T now. So the circuit will look like this. This is 10 ohm and this is R1. R1 is 2.5 ohm. This is R2, that is 7.5 ohm and this is 5 ohm. And in middle you have R3. R3 is 1.875 and I have this 2 ohm resistor. Coming to this branch, as it is 10 ohm and the remaining circuit you can draw as it is, right? So this is terminal B and this is terminal A. Mark all the resistances, right? Now this is that pi network is simply turned into T network, right? This is the T network now, right? Now you can simplify this circuit easily. 10 and 2.5 are in series, 7.5 and 5 are in series, then 1.875 and 2 are in series, right? Similarly this 25 also will come in series with this, right? So 7.5, 5 and 25 are in series. So let us draw the simplified circuit here. So this will be 10 plus 2.5. Here it is 12.5 ohm and then 7.5 plus 5 plus 25. So this will be 30 and 7.5. So totally it will be 37.5 here. Then in the middle I have 1.875 and 2. So that will be 3.875 ohms. And here I have this 30 ohm. And I have a terminal B here. So that's why I cannot add it up, right? Then you have here 10 ohm and 5 ohm that you can add it up, 15 ohm. This is my terminal A. See here 10 and 5 are in series. So these two also you can add up. Now again if you observe this 37.5, 3.875 and 30 ohm, this is again in this pi shape, right? Like this pi shape. Now you can simplify this pi to again star connection, right? So delta to star or pi to T connection you can convert. So if you convert this pi to T, the circuit you will get will be like this. See here, you will get it like this, right? So let us call this as R1 dash, R2 dash and R3 dash. Again you can simplify this. As I said earlier, R1 dash is nothing but the product of the resistances that are lying on both the sides of R1 dash, that is 37.5 into 3.875 divided by denominator is sum of all the resistances, that is 37.5 plus 3.875 plus 30. So if you can simplify this one, this you will get 2.0359 ohms. Similarly, at R2 dash will be the resistances that lie on both the sides of this R2 dash, that is 3.875 and 30. So 3.875 into 30 divided by the denominator again sum of all the resistances, 37.5 plus 3.875 plus 30. So this one 1.6287 ohm. So similarly R3 dash if you do, see this is R3. So for R3 both the impedances here are 37.5 and 30, right? So that will be 37.5 into 30 divided by sum of the impedances, that will be 71.375, this one, right? So you will get it as 15.76 ohms, 7618 ohm, right? So now the circuit will look like this. See, this is my terminal A. From terminal A I have this 15 ohm and then I have this 12.5, right? Then I have this. Now this pi is replaced with the star. So let us draw that star here, or T, right? So this will be the terminal B here as I have simplified. So this is my R1 dash, R2 dash and R3 dash. Now if you clearly observe this one, so this one R1 dash is in series with 12.5 and R2 dash in series with 15 ohm. And again these two are parallel branches. Let us call this as P and Q nodes. So between P and Q I have these two. So that two will be series. And again downside I have 15 and R2 dash. So these two will be series. Again the resultant you will get two branches parallel and then series with R3 dash. Now the circuit is very simple. Let us simplify this circuit again. So I am redrawing the circuit. So 12.5 and R1 dash is 2.0359. So that will be 14.5359 ohm. Then in the parallel branch you have 15 and R2 dash. R2 dash is 1.6287. So that will be here, if you add up 15 plus 1, 16.6287 ohm. Then I have that R3 as it is. So R3 dash, I am writing the value 15.7618. Now the total resistance, that is equivalent resistance between RAB, is nothing but 14.5359 in parallel with 16.6287 plus 15.7618, right? So if you simplify this value, you will get it as 23.5178 ohm. So this is how we can solve the given circuit here. See, the given circuit is like this. So from where I have taken up this pi to t once, and then again we have reduced the pi to t again, so that the simplification became very easy. So like this, if you go, then it is very easy to do the calculation part. Let us see the third problem. Here you are given with a circuit like this, and they are asking you to find out the equivalent resistance between A and B terminals. So if you observe, I have a triangle here, right, inside, right? So this is like a delta. Now this inner delta, you try to convert that into star, right? If you draw that inner delta to star, that will be like this, right? So if you convert that inner delta to star, then what happens? These two resistors will be in series. Again, these two will be in series. These two will be in series. Then it will be easy for us to solve. Let us see that. So name that resistors as R1, R2 and R3. Again, it is like delta to star. So if you can convert that, R1 will be both the sides of the resistances to R1, that is 2 into 2 divided by sum of the three resistances, that is 2 plus 2 plus 2. So that is nothing but 4 by 6, so 2 by 3 ohm. Then similarly, as all the resistances are 2 ohms only. So again R2 and R3 is also equal to 2 by 3 ohm. So if you can replace this inner delta with the star. Now the circuit looks like this. See here, I have two resistors, that is 4 ohm and 2 by 3 ohm here. And similarly, this branch has two resistances, again 4 ohm and 2 by 3 ohm. Again in this branch also 2 by 3 and 4 ohm, right? So this is 2 by 3 and this is 4. Now outside we have a big delta that you can draw, right? So better to draw circuit at each stage so that it will give you a clear understanding. So the outside delta here is 2. Now this is very easy now, right? You can add up these two resistances because they are in parallel, right? Sorry, series. Now if you can add up, you will get one star connection. So that star connection, you try to convert it into delta. Then you will get two resistances here, 2 here and 2 here, right? So that will look like this. See here, I'll just redraw so that you can understand much better. Now see here, after simplifying this 4 ohm and 2 by 3 ohm, that is adding up, I'll get 4.675. So each branch here it is 1.675. So again internally I have a star. So this star, you try to convert this into delta. So if you try to convert that into delta, what I get is like this, right? So then this 2 ohm and this green color, these two are in series, parallel, and again these two are parallel, these two are parallel. Then it will be very easy for us to convert, right? Now let us see how to find out this star to delta connection. So let us find out that R1, that is the resistance in delta, that here you are following that star to delta. So when you are following star to delta, R1 is, the numerator will be product of sum of the resistances, taken product of two resistances at a time. So that will be Z1 Z2 plus Z2 Z3 plus Z3 Z1 divided by the opposite resistance that is lying to R1 or RA. So without getting confused, you just check them as RA, RB, RC. So then opposite to RA, what is that resistance? 4.675, that you take. Okay. So 4.675. So you can take this also as the product of two resistances taken at a time. So that is 4.675 into 4.675. So 4.675 whole square plus again 4.675 and 4.675, right? So like this you can take, because it will be a big term again if I write. So that will be 4.675 again. So what I get here is, if you simplify this, I'll get it as 14 ohm. So similarly, the remaining two resistances, that is RB, RC, also we get it as 14 ohm. Then the circuit looks like this: 2 ohm and then this 14 ohm, right? Again this side 2 ohm and then 14 ohm. Again this parallel branch 2 ohm and then 14 ohm, right? So that you will get. So this is 2 ohm, 14 ohm, and then 2, 14, again 2 and 14. So this is A and terminal B, right? So 2 and 14, you find out the equivalent resistance, that is 2 into 14 divided by 2 plus 14, that will get it as 1.75 ohm. So if you can replace this parallel combination with a single resistance, so what we get here is 1.75, 1.75, and this is also 1.75 ohm. So A, B here 1.75 ohm and 1.75. Here also 1.7. Now, if you observe, these two resistors are in series, right? Again, in parallel with 1.75 ohm. That will be 1.75 plus 1.75 is 3.5 ohm. Is in parallel with here 1.75 ohms. So, the parallel combination, whatever the answer you are getting, that will be your RAB. So, RAB is 1.75 into 3.5 divided by 1.75 plus 3.5. So this you will get it as 1.167 ohms. So this is how you can simplify this problem.
For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.